Hello everyone, we've been learning about the rock cycle in class, and I just wanted to do a quick recording of diagramming the rock cycle. So let's get started. We'll start with the Earth, which the early Earth was basically magma from all the collisions, a lot of heat. So there's a lot of liquefied rock which contained minerals. So we'll start underground with some magma. And when magma comes out of the Earth, it is called lava. This is all liquid rock. It's filled with minerals. It's all made of minerals. And this liquid rock can cool. And when it cools, it will solidify. That means go from liquid to solid. Just like when you take water and you freeze it below 32 Fahrenheit or 0 Celsius, it will solidify and turn into a piece of solid ice. So you can take lava, you can cool it, which will make it solidify into a piece of obsidian. So this is basically frozen lava, and we call that an igneous rock. Now this rock cooled very quickly. There are no crystals in it. If a rock cools slowly underground, then it had time for crystals to grow, and it would make a rock that's, an example would be granite, that has visible crystals in it. Now this igneous rock can be exposed to elements out in nature which can break it down into pieces. So for example, water could fill into cracks in the rock, and when the water freezes at night, it would expand and crack the rock into pieces. This happens day over night. So in the daytime, it melts into water. Nighttime, it sinks in further and expands, and it cracks the rock over time. It's called frost wedging. Other things will break the rock apart, like wind and water moving sand across it, which will scrape it. Many things will break down the rock over time. And breaking down the rock is called weathering. So we're going to weather that rock into pieces. And those pieces are called sediments. They can be all different sizes. Sand is actually just a size of sediment. When you say sand, you're talking about a size of sediment. So we're going to call these sediments. These particles are called sediments. Now over time, these sediments will transport by gravity, which means move, and they will deposit in piles, and that will result in some of the sediments getting buried. Now, when sediments get buried, they get compacted. So we're going to call that compaction. So if you bury something, it will get compacted. It's called compaction. And when it undergoes compaction, it's going to squeeze all the water and air out between the particles. And when the water and air gets squeezed out from between the particles, that will make them cement together, because basically minerals will fill into those tiny spaces between the pores. And that is called cementation. And that's basically gluing together all the particles. And that will result, by taking all the sediments and compacting them and cementing them together, you will make a sedimentary rock, like this example of a sedimentary rock. This has fossils in it. It's the only type of rock that can, sedimentary rock is the only kind of rock that can have fossils in it. And you can see the fossils right in here. So you can see also how this was likely compacted down, which squeezed all the water and air out. And that made it all cement together. All these sediments of all different sizes are all cemented together, forming a nice solid rock. All right. So another example of a sedimentary rock would be this mudstone with large particles in it. Or this rock, pretty cool. It has a fossil in the middle. All these particles are all very small particles, are all compacted and cemented together. And finally, my favorite example of a sedimentary rock that has fossils in it is this rock. This has been polished, so it looks beautiful. But these are all sediments that are compacted together with fossils in them. So those are sedimentary rocks. Sedimentary rocks. You often see sedimentary rocks in layers, like in the cliff walls. Just think of pictures you've seen of the Grand Canyon. Now, these are the only kind of rocks that can have fossils in them again. So you might have a fossil in those layers of rock. Now, over thousands of years, these will get deeply, deeply buried. Another thing that can happen is you could have tectonic plate movement crushing these rocks, pushing them with extreme pressure. This would destroy any fossils. So you can undergo extreme pressure. They can also experience extreme heat. So a rock like this sedimentary rock can be exposed to extreme pressure, crushing it together, or burning with extreme heat, or both at the same time, and that will change the rock, change it to a metamorphic rock. So you can take a rock and change it to another rock by putting extreme pressure and or extreme heat to it. So metamorphic rocks come from other rocks that changed. Some examples of that would be if you took this sedimentary rock, which is limestone, and you put extreme heat and pressure on it, you could turn it into marble, which you can make statues out of. You could also turn a rock like this into slate with extreme pressure and heat. Now there's a difference between foliated and non-foliated metamorphic rocks. These have no foliations, no lines in them, because the pressure was likely from all directions on these rocks when they formed. This rock most likely formed with pressure from all sides. Same with this rock. Pressure from all sides, there's no lines in it. An example of a foliated rock would be this one. You can see the stripes in it. This one was formed by pressure coming down all from one side, from one direction. And then the crystals realigned themselves and made these nice lines. And this is a sparkly rock, which you probably can't tell in this picture, but this is a foliated metamorphic rock. Now you can melt a metamorphic rock. These rocks had already undergone extreme heat. So these rocks have already been very much heated. So this is a rock that's gone through a great amount of heat. Another example of a metamorphic rock would be gneiss. So these rocks go through extreme heat, and now if you take them just a little bit more heat to them, you would melt them. So you could melt this metamorphic rock, and then some of that might rise back up and then come out of a volcano as lava, cool and solidify, and turn back into an igneous rock. So you can start with lava, cool and solidify it to make an igneous rock, weather this into sediments, compact and cement that together, and make sedimentary rocks. And you can take this and put extreme heat and pressure on it, crushing it, burning it, and change it into a whole new rock, a metamorphic rock. So that's the rock cycle. Now, one other thing I want to show you is that any rock can change into any other rock. In other words, you could take this metamorphic rock right here, or this one, any of these metamorphic rocks, and you can weather them. You can take these and weather them into sediments. So you can weather those into sediments, and that can become a sedimentary rock. You could also take this sedimentary rock, and you could melt it with enormous amount of heat, and it could cool off and become an igneous rock. So any rock can change into any other kind of rock. So I hope this helps with your projects. Start with the magma, cool and solidify to the igneous rock. You can weather it into sediments, compact and cement that down, make a sedimentary rock with it. The sedimentary rock can go through extreme heat and pressure and become a metamorphic rock. That will become a metamorphic rock, which could then melt, and you start the whole process all over again. I hope that helped with your projects. Have a great day.